Okay, so welcome to today's session. In the last class, we had discussed about the radial probability and we discussed about the distance from the nucleus, right? So in that we understood that 2s has lower energy than that of the 2p, right?
Yes,
And where I told you that although there is one peak over here, right? And it appears that 2s has higher energy. We need to remember that there is one peak over here. So when we take average of these two peaks, right, the
yeah,
energy
yes.
comes lower than the 2p,
Okay,
correct? And
yes,
and when we talk about when we talk about 2s, right?
yes.
So 2s, what else we need to
Has two
know?
peaks.
Yeah, that I told you has two
Uh,
peaks. Yes. So and this is what a 2s orbital is looking like.
yes,
Okay. So we have a sphere here and another sphere here. Correct?
yes,
Does that make sense?
yes, yes.
Okay. So basically you have this is your first peak and this is your second peak.
Okay,
Does that make sense?
yes.
And if you see this region, there is zero probability,
Okay,
right? Can you see there is a light region in between?
yes. There's
That is,
no electron cannot be there though.
yeah, so that is what is called as a node.
Okay.
Okay, so we have it increases, then it decreases, and then again
Uh,
it increases. Yeah, go ahead.
I'm gonna stay joined in on the device I'm on right now, which is my iPad, but I have like a computer in front of me. I don't have a microphone for it, so can I join in from two devices so
I
I can have your screen on my computer then
Yeah, no problem. Go
uh
ahead, try. Like the only problem with when you are using the two devices is probably the mic. There might be an echo. That is one problem. And second is if you try to share your screen on iPad, okay,
yeah,
and if I try to annotate, I'm not able to annotate.
okay.
So that is the only problem when you're using iPad. Otherwise, I don't think so.
No, it's fine now. I joined the
Okay,
other device. It's easy
okay.
for me now.
Then fine. Till the time we don't have any issues, we can continue.
Okay.
Okay. So this is clear to you, 2s, 2p, right?
Yes.
Okay. So 2p is appearing like a dumbbell,
Yes.
right? And this is what is a probability. So we need to remember this part that if this is 1s, this is 2s, this is 2p. So what I'm trying to represent or what this figure over here is trying to represent is 1s has lower energy, 2s has higher energy,
Okay.
okay? 2p has higher energy than that of 2s.
Okay.
Then 3s has higher energy.
Okay.
After the 3s, 3p has higher energy,
Okay.
okay? After 3p, you see 4s has higher energy.
Yes.
After 4s, it is not 4p, it is
Okay.
3d,
Okay.
okay? And after 3d, we have 4p.
Yes.
Okay, and this is what I told you when we did the filling of the electrons in the electronic configuration. If you remember, I didn't tell you this concept in that class.
Okay.
But what I told you is when we have the periodic table in front of us, we know that the first groups are S.
Yes.
Then we have the first two groups. Then we have
Yes.
3 to 12,
D.
which are D, right? And
Yes.
then we have 13 to 18,
P.
which is P.
And then the
And
other
then,
one is F.
yes, at the bottom we have F, right? In that, I told you that if it is S, we stay NS. If it is P, we stay NP. If it
Yes.
is D, it is N minus 1. And if an
And minus
electron is
two.
an, yes. So that concept is actually part of Aufbau's principle, which states that the electrons are filled in the orbitals in an increasing energy,
Yes.
right?
Yeah.
So how the electrons are filled in an atomic orbital? In the increasing energy. Start from lower energy and gradually goes to the higher energy. Clear?
Yes.
Okay. So that is what is the concept of Aufbau's principle. Okay. Then energy like, and that is what is your energy level diagram. So this is an energy level diagram.
Okay.
Okay. So when we talk about the hydrogen 1s1, this is hydrogen 1s1. So we represent the 1s orbital and we represent one electron. When
Okay.
we talk about helium 1s2, we talk about this orbital. 2s and 2p is empty.
Yes.
Okay. When we talk about lithium, check 1s, 2s, 2p.
Okay.
So what is this? The the stairs indicating that they are increasing energy.
Increasing energy. Yeah.
Okay. And okay. So procedure of writing electronic configuration, use the periodic table to determine the number of electrons in an atom or ion. Okay. Assign
Okay.
electrons by main energy level and then by sublevel using an energy level diagram or an Aufbau's diagram. Distribute the electron into the orbitals that have same energy according to the Hund's rule.
Okay.
Fill each sublevel starting before starting the next sublevel.
Okay.
Okay, meaning you have to first fill the electrons in the 1s.
Okay.
After 1s are completed, then you will go to 2s.
Okay.
Okay, let us talk about nitrogen over here. Nitrogen has how many electrons?
Uh, I will
Five,
check it. Five. Okay.
right?
Yeah.
No, sorry, not five. Five is the outermost.
Seven.
Seven. They have total seven electrons. Okay. If you look at the periodic table, is the periodic table in front of you?
Yes.
Okay. So if you look at the periodic table, check the position number 7 on the periodic table. You will
Yeah.
realize that it is coming under second period, right?
Uh, yeah. So the second thing. Yeah.
Wait, what I'll do is, yeah. So let me share the screen with you. Okay, can you see my screen
Yeah.
with the periodic table?
Yes. Yes.
So now what I told you is you have nitrogen, which is at the seventh position, correct?
Yes.
Okay,
Yes.
that seventh position is in the period 2, correct?
Yes. Correct.
So that means there are two energy levels.
Yes.
So when there are two periods, means there are two energy levels.
Okay.
Energy level 1, which is lower energy, energy level 2.
Okay.
That 2 is further subdivided into 2s and 2p.
2P. Okay.
Okay,
Yeah.
does that make sense? So
Yes.
we have 7 electrons. So first you will fill one electron, then you will fill the second electron.
Okay.
1s is complete.
Okay.
Then you will go to 2s. One electron is complete, second electron is complete. Then you go to 2p. 1, 2, 3. Does
Okay.
that make sense?
Yes.
Okay. If I have, let us say phosphorus. What is
Yeah.
the number? 15.
15.
15. Which period? 3.
3.
That means there are three energy level. 1,
2.
2, and
2.
3.
Okay.
Okay. So this is 1. When you have 2, that means you have 2s. Sorry. When you have 2, 2s, 2p. When you are in 3s, 3s, 3p. Correct?
Yes.
So I made the 2s and I made the 2p.
Yes.
Okay. Then I make the 3s and then I make the 3p.
Okay.
correct?
I have a question. What is this type of table called?
Energy level diagram.
Okay, energy level diagram. Okay.
Yeah. So either you can use Aufbau's rule or you can use a periodic table. I've seen like uh, students are more comfortable with the periodic table than they are comfortable with the Aufbau's rule.
I feel like I'm more comfortable with the periodic table as well. It's
Yeah,
simpler.
because the periodic table is handy when you are in the exam or when you are trying to
Yes.
be so. But Aufbau is not difficult. The drawing is, but anyways,
Okay.
either of the option can be used, so we can select anyone. Okay, now let us talk about filling of the electron. How many we have? 15.
15, yeah.
Yeah. So when we start, what is the rule says? Fill the lower energy orbital first, complete them, then go to the next.
Then go to the next one, yeah.
Right? So first
Yes.
we'll fill the 2s, sorry, 1s, then we'll fill the 2s, then fill the 2p, right?
Yes.
And if you notice over here what I did, I first gave one electron to each, right?
Yes.
And then for the 2p level, I filled one electron each, and then I filled them by the what do you say, reverse spin. Does that make sense or no?
Mm, could you repeat that?
Yeah. So what I told you is four electrons are done, right?
Yes.
After four electrons, we have 2p orbital.
Yes.
So I have around 11 electrons pending with me.
Yes.
So this I gave one electron to each,
Yes.
correct? This is called as half filled state.
Okay.
So we had the 2p orbital where I gave one
Yes.
electron each. And if you check the spin, they are pointing upwards.
Okay.
Now the extra electron will not go to 3s
Okay.
because each orbital can have maximum 2 electrons.
Two electrons, yes.
So now I start filling these with inverse spin.
Okay.
Why? Because you remember all the electrons will have three quantum numbers same. If they have three quantum numbers same, the spin quantum number will be different,
Okay.
right? So I
Yes.
reversed it. Then I go to the next. Now still I have four electrons. Sorry, no, for five electrons. One, two, three, four. So I think, sorry, 10 are done. Five electrons are still pending, right? So I'll give
Yes.
3s. I'll fill that. Now I'll go to 3p.
Okay.
Okay. Can you write down this for the phosphorus?
Okay.
Give me 1 minute. I'll be back.
Okay.
Yeah, I'm back. Okay. Now, before going to the next concept, I want you to try arsenic. Okay.
Okay.
Uh, and share the picture with me on WhatsApp. You have my WhatsApp number?
No.
Okay. I think I have your number. I'll just type in my number on that. I generally used to send the link. I generally used to send the link to you.
I think you sent it to my mom.
Okay. So now, okay. Do you know that you have I have shared the, uh,
I have your email though. I
yeah,
plan on email.
yeah, you have my email. In that signature, you have my number.
Okay, okay.
Just check.
No, let me double check if I have that. Your email?
Yeah.
No, I can just reply to your email with the picture of it.
Okay, no problem. It takes time for the email to come. Generally, the WhatsApp is faster.
It could still kind of work.
Okay, no
I'll
problem.
try.
Do, yeah.
Uh,
Whatever you're comfortable.
so for arsenic,
Yeah.
arsenic.
Yes.
Arsenic has 33 electrons, right?
Yes.
But there's only four energy levels.
Four energy levels. So four energy levels. You have the periodic table in front of you.
Yeah, yeah,
So when you make four, just realize, just check. One has only one energy level. That is
yeah,
one S.
yeah,
Two has two energy levels.
yeah,
That is 2s and 2p.
yeah.
Three has three energy levels.
That is 3s and 3p.
So 3s,
And
3p, and 3d.
3D.
But
Okay,
3d is between 4s and 4p,
okay.
right?
Okay, so then I fit in the four. Okay. And for 3D, how many boxes do I make?
There are for 3d. Can you count the number of boxes on the periodic table?
3D. Three.
No. How many? How many elements in the D? How many elements in 3D?
D is the middle one, right?
D is the middle one. Yes.
Yeah, 10.
10. That means 5 orbitals.
Okay, okay. And that's gonna be in the fourth energy level, right?
That's in the fourth energy level. So the energy level goes the same way as you see. So that means 1s, then you has 2s, 2p, then you has 3s, 3p. After 3p, you will have 4s. After 4s, you have 3d, and after 3d, you will have 4p.
4p. And 4p is four.
Yeah.
4p only has four. Okay.
Yes. 4p has three, like 4p has total six, three boxes.
3 boxes. Yeah, I messed it up. It has three
Yeah.
boxes. Yeah.
Yeah. Okay.
I have it.
So
So instead of sharing, I feel like it'd be easier to tell you. So
no problem.
for
I'm drawing it for you. So I have 1s,
1s
then
and
I have
then
2s, 2p,
2s, 2p,
then I have
3s,
3s. After 3s, I have 3p.
and then
After 3p,
4s,
I have 4s. And
and then
after
4d,
4s, no, 3d.
3d, 3d, yeah, sorry.
N minus 1. D means n minus 1. And
Yes,
after 3d, I have 4p.
4p.
And when we talk about s, there is only one. S is only one. P are 3.
3, and
S is
then
1. P
d.
is 3. S is 1. D is 5. 1, 2, 3, 4, 5. And P again is 3.
Yes,
Correct?
yes. So they're all gonna be full with two
So,
electrons,
except for the last
except
P.
for 4p. 4p
Yeah.
is gonna have two two like shells full of electrons, and then one with only one.
Check the way I'm filling it. Did you do the same?
Yeah, yeah, with the
But
arrows.
do share the
Okay,
image
I'll
with
take a
me.
picture right now. I'll take a picture right now.
Yeah. Okay. 1, 2, 3, 4, 5, 6, 7. I'm sharing the screen with you, right? Where I'm
Yeah,
drawing
yeah,
it.
yeah. You are.
Yeah. So 1, 2, 3, and 4.
Mm,
So this should be the answer for you.
okay. Let me count it again.
Yeah. So it was 4p4. Arsenic was 33, right?
Yeah,
So 33, let me count. 2. So it is 2, 4, 10, 10, 12, 12 plus 6, 18, 18, 20, 20, 30. Okay,
30.
then I made a mistake. Yeah, 4p3.
Okay, okay. For the arrows, I did the same thing. The left arrow was pointing down though, and the right one was pointing up. That's the only one I
Oh,
think I
that
missed
that
there.
should be okay.
That
Till
should
the
be
time they
okay?
are opposite spin, it should be okay.
Okay, okay.
So that's the
Is
reason
that
I wanted to see the image, how you have done it.
okay? It is sending.
Yeah, so it takes time. WhatsApp is faster.
After this, I'll make sure you have your number on WhatsApp.
Yeah. Mm, I sent an email with my number.
Okay. I'm just gonna reply with that with the image.
Okay. If you could WhatsApp me, it would be better.
Yeah, I'll WhatsApp right now then. Okay, I sent it.
Yeah, received it.
And the numbers on the side, the 8882, that was just my own counting. It's not a part of it.
That's fine. Yeah. 2 2 2p6, 3s2, 3p6, 4s2, then 3d10, 4p3. Yeah. And now if you write, like if you have to do the electronic configuration, there's another concept which is
Yeah.
electronic configuration. Okay. So if someone asks you what is the electronic configuration,
Yeah.
so the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6,
The two no, the
4s2.
number beside the on the right side of the letter is indicating how many electrons there are, right?
Yes.
Okay.
And 3d10, 4p3. This is what we did in the last class actually. I
Okay.
directly started with electronic configuration. However, I should have started with the orbitals and then went to the electronic configuration. I realized that.
Okay, okay.
Okay. So, but have you
That's fine.
understood this part?
Yes.
Okay. Now, now there are a few more concepts in this, and that should conclude the unit. What am I sharing with you?
You're just sharing my work.
Okay. Now,
Now it's a thing. Uh,
okay. So we are done with the electronic configuration, periodic table explanation. I had already done that. Okay, so this is what we know when it is 1s, 1s. So S is the group 1 and 2, right?
yes.
Whenever it is P, and I told you that helium is an exception. You remember
Yes.
that?
Yeah, yeah.
And then 13 to 18 is p orbital,
Yes.
and 3 to 12 is d orbital,
Yes.
and then these are f orbital,
Okay.
right? So if you check, lanthanides and actinides are part of, sorry, lanthanum and actinum is part of uh, the d, whereas element after that is part of the f.
Okay.
You remember, like even we did in the last class, I had explained that to you.
Yeah, yeah. You explained the how they fit and stuff.
Yeah, okay, good. So that's done. So electronic configuration, I think you'll be able to do that. Okay, then explaining ion charges. Okay, so now it's easy to understand what would be the charges for the elements. Now, for the transition, why they are transition is because they have more than one charge on them,
Okay.
right? So
Yeah.
now if you look at this, the electronic configuration for neutral cadmium atom. So this is the neutral cadmium atom, right?
Yes.
It shows that cadmium atom has 12 electrons in its outermost orbit.
Okay.
Cadmium forms 2 plus ion. Why? Because the 5s is the one which is easy to donate because that is the outermost,
Okay.
right? Alternatively, cadmium atom gives up 10 electron and leave the field 5s orbitals. However, this possibility is very unlikely, meaning that it prefers to give 2 electrons or 10 electrons, right? So it will definitely give 2 electrons, right?
I don't get it. Could you
Okay.
explain it?
So what I was telling you is, if you see this cadmium,
Yes.
right? Cadmium is electronic configuration is krypton, right? Which is
Okay.
the previous neutral atom. Sorry, group 18 atom.
Okay.
Then I have 5s2 and 5d10, 4d10. Sorry. Okay.
Okay.
Now cadmium forms 2 plus ion,
Okay.
correct? So to
Yes.
form the 2 plus ion, it gives out the 2 electrons, correct?
Yeah. The two. Okay. Yeah.
Yes.
Outermost.
So
Yes.
alternatively, cadmium atom could give up 10 electrons and leave filled Fs orbital.
Okay, so there's a possibility that it could give away all the electrons in the fourth outermost shell instead of the fifth
Yes.
one.
Yes. So
Okay,
that
okay.
is highly unlikely.
Unlikely, but it's still possible. Okay.
You have to provide that much energy. See, one is about uh, theoretically speaking, everything is possible.
Yeah.
You have to bring in infinite energy,
Yes.
right? So, so when we talk about concepts here, we talk about only energy that is possible to give. We never
Okay.
talk about infinite stuff here.
Okay.
Okay, we never talk about infinite possibilities.
Yes.
We mostly try to explain what has been the common observations.
Okay, like
Okay,
realistics and stuff. Okay.
yes. So which is common, that is what is there on your text,
Okay.
right? So for example, lead plus 2 plus 4.
Yeah.
Why lead is able to form plus 2 and plus 4, two electronic configurations, sorry, two ionic charges,
Yeah.
right? So in that case, if you see the electronic configuration of lead, xenon, group 18 element, the previous one to of that group, then
Yeah.
6s2, 4f14, 5d10, 6p2, right? So now it makes more sense. If you observe 6, right?
Okay.
So two electrons from here can go, right?
Yeah.
That will become plus 2.
Okay.
If two electrons from here are lost, so this makes it plus 2, this makes it plus 4.
Plus four. Okay.
Okay, the inner ones, you don't generally remove those electrons, it is only
Yeah.
the outermost.
Those are harder to remove
So
primarily.
those,
Yeah.
yes, so those, although those are higher energy level, whenever we see what you say, whenever we see the higher principal quantum number, right, we remove the
Yes.
electron from the higher principal quantum number.
Yes. But
Okay.
why is it written like that? Why is it PB and then XE and then
Oh, that PB is the element,
yeah.
and instead of writing the entire electronic configuration starting from 1s2, 2s2, 2p6,
Yeah.
and so on, the shorter version is to write down the previous inert gas. If
Okay.
you okay, let me go to the periodic table
But
one.
where XE but XE is in a different group.
Sorry. Yes, I'm coming to that. Give me 1 minute.
Uh,
I'm coming to that. Where is the periodic table? Yep. Here is the periodic table. I'm sharing the screen, which is containing, okay, the PDF. So I went to the
oh, okay.
period.
I understand it. I understand it because all the most elements are already full shells.
Yes,
This and then whatever is below it is just built upon
correct. So now
X.
if you
Okay, okay.
see, can you see the screen?
I understand. I understand. Yeah.
So
Yes.
xenon, right,
Yes.
represents all the electronic configuration till here.
Before, yeah. And then
Okay, and after that we are just representing the outermost electronic
sixth group.
configuration,
Yeah.
that is 6s2.
Yes.
After 6s2 we have 4f14, because that we have the 4f.
And
Then
then
we have 5, and
5D.
then we go to 6p.
Okay.
Make sense?
Okay.
It's done. Okay, now let us talk about magnetism. Okay,
Okay.
so
Okay.
iron, if you see, has three unpaired electrons,
Yes.
right? Cobalt has, sorry, four unpaired electron. Cobalt has three unpaired electron. Nickel has two unpaired electrons.
Yes.
Correct?
Yes.
Right?
Yes.
Okay. So now remember one thing. If you have more, so there are two things. One is paramagnetic and diamagnetic.
Okay.
Okay. So there is paramagnetic, or three concepts: paramagnetic, diamagnetic, and ferromagnetic.
Okay.
Okay. So let us understand what is para.
Okay.
Okay. This is my way because I believe even you know Hindi.
Yes.
Read para as pyara.
Pyara. Okay.
Okay. So that means loving,
Yeah, I understand.
right? So
हाँ
that
जी.
means if it is a paramagnetic compound, that
Okay.
means it is magnet loving.
Okay.
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 So if it is magnet loving means what?
There
It will be
it
attracted towards the magnet.
electrons.
So it is attracted towards the magnet,
Okay.
right? And diamagnetic is opposite of that.
Okay.
Hate magnet. So they will be repelled.
Okay.
Okay. Does that make sense?
Yes, that makes sense.
So paramagnetic are magnet loving, diamagnetic are hating the magnet. Now,
Okay.
what decides which is paramagnetic and which is diamagnetic? The
Okay.
number of unpaired electrons.
Okay. Okay.
So if
Yes.
you have more unpaired electrons, it is paramagnetic.
Para.
If
Less
you have
is the.
more paired electrons, it is dia.
Okay.
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 So that means here you have paramagnetic properties as well as diamagnetic properties, but the diamagnetic properties
Or
are more.
more.
So it is more diamagnetic than paramagnetic.
Okay.
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 Now there is third concept that is ferromagnetic.
Okay.
Ferromagnetic is are compounds which are having domains. So can you see these blocks,
Yes.
right?
Yes.
So these blocks are having the electrons in the same directions in each
Okay.
block,
Okay.
correct?
Yes.
Right? And basically, because the blocks are randomly arranged, they have
Yes.
no magnetic field of their own.
Okay.
Okay, so basically, they don't have any magnetism of their own.
Okay.
However, if they are brought under the influence of a magnet,
Yes.
what happens? All the electrons are taking a particular direction. All
Towards a
the blocks,
magnet.
yes,
Okay.
right? So
Yes.
then that means this start behaving like a magnet.
Yes.
Okay.
Okay.
So
Okay.
iron starts behaving as a magnet after some
Yes.
time, and that is a temporary effect.
Okay.
Okay. After you remove the magnet, after some time, the magnetic property of iron is also lost.
Gone. Yeah.
Because what happens? These domains which were aligned, they
The.
gradually start going back to their original random state.
Okay.
So that is what is ferromagnetism.
Yes.
Okay. So paramagnetism is weak attraction of a substance to a magnet, applies to individual atom.
Yeah.
Strong magnetism commonly exhibited by materials that contain nickel, iron, and cobalt applies to a collection of atoms.
Okay.
Okay. Any doubt?
No.
Okay. And then I told you what is diamagnetic and what is paramagnetic.
Yes.
Okay. Paramagnetism.
Yeah. Likes is
Yeah.
likes
It likes
magnetics.
magnet. Diamagnetic doesn't like magnet.
Does it?
Okay. I believe we are done with this unit.
Okay.
We like yeah, that should be all. Okay. One concept I'm pretty sure that will come to you. I There are some exceptions to the electronic configuration.
Okay.
Okay. I want you to write down the electronic configuration of manganese.
Okay.
Okay. Can
Okay.
you write down that?
Can you show the periodic table?
Yeah, sure. And I want you to tell me the electronic configuration of manganese.
Okay. So I'm gonna send a picture on WhatsApp.
Hi, sorry.
I'm gonna send the picture on WhatsApp.
Yeah, please. I'll stop sharing this part then.
Yes.
Let me see what you have shared. Okay. No.
I have a question.
Yeah, go
I
ahead.
I add an electron to 4p.
Wait. I'll tell you what is the mistake.
Okay, okay.
So, can you see my screen?
Yes.
Okay. So, how many? 25 electrons, right?
Yes.
And if you look at the periodic table, I told you manganese, right? It's
Yes.
part of the fourth. So, we have 4s and we have
Yes.
3d. Does
Yes.
that make sense?
Yes.
Okay. Now, let me see you what you have made. You have made 4s, you have made 3d, and you have made 4p. That's fine.
Okay.
This is absolutely fine. So basically, this is your 1s, this is 2s, this is 2p, this is 3s, this is 3p,
3p.
this is 4s, this is 3d,
3.
and this is 4p. That's fine. Orbitals
Okay.
are okay, no problem with that.
Okay. Okay.
Now 1s2, two electrons are done. 4, 10, 12, 12 plus 6, 18, right?
Yes.
Now Hund's rule, fill the orbital first,
Okay.
right?
Then go to the next
Then
one.
go to the next one,
Okay.
right?
That's the mistake I made. Okay.
Yeah.
I was gonna ask that question. Should I have filled it up?
Yes. So
Okay.
that is what you need to fill the orbital first.
Should I fill
Then you
3D as
can go
well?
to the next level. Yeah. So when there, that means this electron is not correct.
Okay. And the same thing
Okay.
for 3D?
Yeah. 3D will have 111.
Okay.
So
Until
this is one level.
okay, okay. Okay, I get
Okay.
it. Yeah, yeah.
And then after that, wow, like this state is called as half filled.
Okay.
So half filled state is more stable. So you will give one electron in each, and then
Yes.
only you will start coupling.
Okay.
Okay.
Yes.
Does that make sense?
Yes, that makes sense. But I still show the empty orbital thing.
That's okay. That's fine. If you show it or you don't show it, that's fine.
Okay.
Not mandatory thing, but if it is, I want you to remember this because when we go to the next concept, chemical bonding, we should know
Okay.
that there are some empty orbitals. They come into picture there.
Okay. Okay.
Okay,
Uh,
so it's better to know the concept.
okay. I was also gonna say, can we end this like a couple minutes earlier? Because
Yeah,
I
sure,
ha
no
I have to
problem.
go somewhere.
No problem. Let
Okay.
us first finish this concept at least.
Okay. Okay. Okay.
Okay,
All
because
right.
I have one more like after this, I want you to try
One more.
uh, chromium.
Chromium. Okay.
Okay, and I want to tell you what is the difference, why I'm emphasizing on these.
Okay. Can you share chromium?
Chromium is 24,
24. Okay. It was right next to magnesium. Not magnesium.
manganese.
Manganese. Yeah. Okay. I'm gonna send a picture. I sent it. Oh,
Yeah,
yeah.
yeah.
Okay.
Okay. So now 4s2. Now can you see this? You have made
Yes.
1, 1, 1, right?
Yes.
What you drew is correct, absolutely correct.
Okay.
Okay. This is what is called as theoretical electronic configuration.
Okay.
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 Theoretical. But when we talk about practically observed, we have
Okay.
four. There is one electron here. Okay.
Yes.
And in the D,
Yes.
okay, one electron from here goes to the empty D orbital.
Okay.
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 Why does that happen is because you remember I told you
It's
half
more
filled are
stable.
more stable. So what
Yes.
happens? And the gap between 3D and 4s is narrow.
Yes.
For that extra stability, the electron makes that jump.
By itself. Since
Yes.
very little. Okay.
Yeah, because the stability is more.
So if like my teacher asks the question, will this specify theoretical or
No,
real
they
life?
yes, they will ask you. These are exceptions. So
Okay.
whenever you notice that if it is 3D4, you don't have to think. You have to transfer that.
Okay. Okay.
Okay.
Okay.
So because when we talk about electronic configuration, we talk about the actual electronic configuration.
Yes.
Okay. We don't say whether theoretical or practical.
Okay.
When you write this, that means you have made a mistake.
Okay.
Why? Because you have just concentrated on the theoretical aspect of it,
Theoretical.
but you
Yeah.
missed out on the stability part.
Yes.
Okay. So
Okay.
does that make sense?
Yes, that makes sense.
Okay. Then another example, maybe now you want to leave, you said, but another
Yeah.
example that you should do is copper. Okay. You can try that later on. Okay.
Okay, I'll try that. And then I'll do, can you give me like a number? Like three, four
29.
elements?
29.
Okay, can you give me a couple thing?
Yeah, sure. Tell me.
Like, can you give me a couple elements and then
Okay.
I'll
Okay. I'll give you molybdenum MbMo, sorry, 42,
42. Okay.
tungsten 74,
74. Okay.
then cadmium, sorry, silver,
Silver, how much is that?
uh, copper and gold.
How many, what number is silver?
Silver is 47,
Okay. Copper,
copper is 29,
29.
and gold is 79.
Okay.
Okay.
I have them complete and then next class you can take
Yeah.
them up.
So that means we are done with this entire unit and we can go to this chapter, and then we can go to the new chapter in the next class.
Okay. All right.
Okay. No
All right. Thank
problem.
you. Have a good day.
Okay. Yeah. Bye.
Goodbye.